Right, so firstly, thanks John for inviting me. And I'm actually standing in for a colleague of mine, Martin Dean, who can't be with us today because of sort of health issues, and so I'm afraid you're going to have to put up with me. So this has all sort of been put together at rather short notice, so I just apologise for that. Microphone. Oh, microphone? Yeah. Oh, yes. Okay, can you hear me? So anyway, I'm going to take you through a few things that ADAS have been up to over the past year. But the theme of the talk really is not just showing you nice pictures of surveys and visualizations, but it's also really that discussion about value. What does high-resolution surveys and what does 3D visualizations actually bring to your client or bring to our clients? So I'm going to try and sort of really sort of carry that theme through the talk. And also, I'm very aware that earlier this morning you've seen some fantastic presentations from the Port of London and also from Duncan. So I feel as I'm competing really at the top end here, which is great. But we'll see how we get on. So just a short history. ADAS was spun out from the University of St Andrews. So the founders, Martin Dean and Mark Lawrence, really come from an archaeological background. They're marine archaeologists, passionate about diving, passionate about shipwrecks, passionate about our sort of subsea, our sort of human culture subsea. And the best way to investigate and to study marine archaeology, obviously, is originally through divers. So divers would go down and create plans and understand the context and the way that shipwrecks have sunk, or the way that if you had a drowned landscape or round houses under the water. The idea really is to get a really good understanding of the context of that environment. And after they've been sort of diving for a few years, they realised it'd be a lot easier if they could acquire that data remotely and get some contextual data. So that's when they really started investigating hydrographic survey techniques. And that's really where it comes from. And they developed some unique methodologies, and also then sort of developed a relationship with the University of Dundee and their visualization department. So they started looking, sort of about 5 years ago, about the best way to really visualize and present this 3D data, as I say, mainly of shipwrecks. And today I'm going to sort of concentrate on shipwrecks, because it's really where we come from. But, this obviously, the technology and the themes really run into all sorts of different market sectors. As you've seen this morning, offshore wind is obviously very exciting, and also oil and gas is very exciting at the moment, because obviously there's a lot of pressure to extend oil fields and increased engineering without any sort of new production. So therefore, there's a requirement within oil and gas for as-is and knowledge about what assets are on the seabed. So, as I've sort of said before, as I was sort of waffling at the beginning trying to get the presentation together, what we really specialise in is high resolution, and it's structural surveys. We're interested in structures. We're not necessarily interested in bathymetry per se. We're not a sort of standard survey company per se. And from that high resolution data, we create 3D metrical interactive visualizations from which we can derive engineering drawings, and hopefully contribute to engineering solutions. Just an example of some of the things we've been doing recently, and again, just an idea of that sort of detail of survey. So the idea is that we collect data, and through that data, really we see data as the interface. Data is the first stage for any project and for any sort of engineering solution. So data really is the interface. So from data, that gives us information and knowledge, and hopefully that should supply better decisions, or good decisions. I wasn't actually going to go into this, but I think the first project that ADAS undertook was, again, our main sector in the salvage industry. It was quite clear. We got flown out at sort of an emergency notice to a wreck in the Straits of Malacca. They'd been looking at this wreck with divers. Divers had been annotating a plan, and we came along and did a survey using a multi-beam echo sounder. We managed to visualize it differently from previous surveys that had been undertaken, and basically the salvage plan changed and saved the salvage company something in the order of sort of 60 million quid, which, well, no short change for us, certainly. So again, the value Pre-cert salvage planning, but of course we can take this into other sectors, costings, and indeed we can easily sort of use our data in an operational sense in real time and start flying ROVs and divers around sort of the wreck form to give us a better understanding of where people are going and what people are doing. And then obviously post-salvage, there's the clearance side of things, and then there's the forensic evidence. And in fact, some of our surveys have been used in the legal arena, really, to prove clearance and that sort of thing. Right, but as I said, we're not doing anything special particularly. We are using a sort of an array of standard survey and hydrographic techniques. And when I say standard, obviously I don't mean to put the Teledyne products down. Obviously top of the range, wonderful equipment. We always use, we try and maximise the quality of data by using the best quality equipment. And that goes from subsea laser through to multi-beam, and indeed in-air laser as well, which I know you've already seen this morning as well. Okay, and also working from a variety of platforms, from ships to ROVs and alike. So I'll just try and give you a bit of a case study now. Costa Concordia, hopefully we're all familiar with, who's now safely in an Italian breaker's yard, I think. So we were called in initially by the salvage operation to get so that they could get an understanding of the wreck. You know, if you're faced as a salvage operator, how are you going to go from this to this? The one thing you do need is information. You need the best information, because I think this still stands as the most expensive salvage operation to date, running into sort of billions of pounds. I don't know the exact figure. But the key thing there is information and knowledge. And so the salvage operation revolved around the idea of righting the wreck, and then putting these flotation sponsors on the side. Have we got a laser pen here? Oh, that's fantastic, isn't it? Let's look at it. Right, so you can see here that the idea, she's on her side. The idea is that they put sponsors on the side here, and the ship is actually going to be power buckled. These are actually stakes in the seabed with chains running around to these sponsons, and the idea is to right the ship and then eventually sort of float her off. Right, so initially we went and did a survey, and using, in this case, multi-beam and also aerial drones, and we were able to sort of create this image. And obviously this is quite informative because it shows that the wreck is actually pinned on these sort of two rock outcrops, and there is actually free span between those outcrops where the wreck is spanning, and you can actually get divers under there and equipment. Right, another thing again for the engineering design to facilitate the power buckle, they wanted some frames made so that you could actually put, if I just go back here, so you could actually put some, attach these wires and sponsors onto different parts of the ship. So one of the tasks we were given was to actually survey the thruster ports that actually engineer a mountain that would take the power buckling wires. So we did that just with a standard laser, scanning laser, which was mobilised by divers inside the thruster tubes, and we produced images like this to sort of obviously millimetric accuracy, which led to engineering drawings like so. And this plug was actually put into the thruster tubes, and then wires were attached to these to aid the power buckle. Right, then moving on for that, when it actually came to the power buckling, again we were called in, and what was required was a survey when she was upright, when the power buckle had been completed, 18 hours of tense, nervous headaches while the ship was slowly being righted. And then at this point, when the ship was righted and the party had started, we actually were called in to do the survey. Okay, and again, the idea was that these sponsons that you see on the port side, they needed to engineer so they could put those on the starboard side to aid the flotation. Again, this is our survey on the port side. Just to give you an idea of the equipment, so we mounted an in-air laser, a Regal laser on the top of the pole, everything mounted on the same pole. Then we had, can't quite see the in-air laser, but it's up there somewhere. Then we also had a subsea laser here, 2G robotics subsea laser, and of course 7125, the workhorse, our workhorse really. Okay, all mounted on a multi-cat, oh my word, all mounted on a multi-cat so that we can undertake a simultaneous data acquisition with all three sensors. Right, and also while this was going on, we have very close relationships with a company called Cyberhawk, who were flying these drones in the air to sort of give an idea of the aerial scene, but also to undertake sort of photogrammetry, so we could actually get a point cloud from the photogrammetric data from the aerial drone, which proved interesting. Okay, so here we are using the laser. So basically we split the wreck into three. We had the top sides that we surveyed with the in-air laser, then we did this mid-section with the in-water subsea laser, and then we surveyed the rest of the hull with a 7125. Right, and produced this sort of image here. This gives you an idea of all the data put together. So you can see this is actually the power buckling wires here. This is where the ship has been resting on the rocks, and this is actually part of the sponsons that were attached on the port side. There's another image there. And yeah, I just put that in just to show you that the idea is that these sponsons needed to be attached here. So a full damage assessment really needed to be made of those points where the wreck was in contact with the rock. Right, and there's just a quick photo of the damage. And here's an idea of, now this is actually produced by the aerial drone. This is actually sort of photogrammetric and colour data. And also, actually, I think that's laser data, sorry, I do apologise, that's actually coloured laser data. And here we start sort of zooming into that laser data to get a better idea of the sort of resolution that we were getting. So we're starting to pick up the rope, the handrails, and a bit of detritus around here of the wreck. So that's giving us quite a lot of resolution. And actually what we found was that the subsea laser here was actually a little bit better than the in-air laser in terms of resolution. And I could be very adventurous here, and at the end I'll show you a video which really zooms into that, which is zoomed into the undecimated laser data. This is still actually decimated just for the imagery. Right, and there's just another example. So we're getting davits, we're getting ropes, we're getting cranes, and actually in this picture, I don't know if you can make it out actually, but you can actually just about see the raised lettering that says Costa on here. So that's giving you an idea that that's a 20mm bit of raised lettering of the name of the wreck, which comes out in the laser data. But the point is, as I was sort of trying to say at the beginning, it's all very well producing beautiful imagery, but the real value is in the use of that imagery and how the engineers, the naval architects, and indeed the sort of salvage operators use that data to assess their next move. So what we've done here is we've actually we've impregnated the GA plan into the 3D point cloud. So we can then we can start taking direct measurements from the point cloud data from the GA plan. So we can start really assessing the deformation of the hull. Right, and there we go again. So this is here's the GA plan which we've rectified. We can see here how the hull has actually been deformed as it's been on the rock here, and everything else sort of matches quite well, and there's a bit of deformation up here. Okay, again, so the point is that the high resolution data is giving you that extra bit of knowledge to make that extra quality of decision making when it comes to the engineering design. Right, and here we go again. So again, up here we can actually start overlaying the actual damage, comparing that to where the deformation stops, and actually making some quantitative measurements from the wreck, right, from the GA plan, again using the point cloud data. So no interpolation here, just purely using the quality of the data. Right, so that was the Costa really. So we're involved from start to finish. And all the way through we were sort of liaising with the engineering teams, and in fact it was quite interesting because at the end of the day the engineering teams could only work in sections. So the quality of the 3D visualizations actually enabled us where to choose the sections for that sectional data then to be put into the naval architecture programs from where they were designing the sponsons, the flotation and the disposal of the wreck. Right, so I just thought I'd give you another example of the RENA project. the Rena. The Rena was travelling past New Zealand and unfortunately ran aground on the only wreck, the only reef in the Southern Ocean, well not quite, but on the Astrolabe Reef, which was always had been a reef of special scientific interest, very popular locally and had a lot of cultural meaning to the local Maoris. So this was, and indeed is an ongoing saga, and any shipwreck is a huge issue, but this was a particularly huge issue because of the value of the seabed in that area, and produced an awful lot of, quite a scenario in terms of how much the wreck should be salvaged, etc. Okay, so here she is on the reef. And she sort of slowly broke up. The salvage effort went through sort of various stages, whereby the containers were removed, the wreck began to sort of be broken up, and then she slowly moved. This is an incredibly dynamic area. I mean, this is a nice day, and you can see that we've already got sort of 2 metre swells over the reef. So whenever you go out here and survey, you're always challenged by the conditions. But yeah, so we went out twice. We went out when the wreck was first salvaged initially, and then we went back this year for a comparison data set and to actually analyse how much of the ship had been cleared. So here we are using this wonderful little survey boat.